Good morning, guys, and welcome to our lesson today. Today we are going to start talking about 10.2, okay? Just as a heads up, so make sure you checked over your homework on 10.1. We only have, a little over a week left in the marking period, so if you have any assignments that you didn't forgot to hand in, anything like that, please let me know. We're going to have one last quiz for the marking period on 10.1, 10.2, and 11.3, most likely Monday or Tuesday. Make sure you're reading my posts on Google Classroom and my Remind 101 to get updates on that. Okay? If you have any questions, like I said, continue to contact me, ask me, and I will get right back to you. Let's get into it. So what is a central angle? And it's really exactly what it sounds like. A central angle is an angle whose vertex is the center of a circle and whose sides are radii. So, for example, center of the circle is center P. The sides of the angle are radii. So that means angle APB or angle BPA is going to be a central angle. It just basically means that the vertex is at the center. A circle, which we know, if we were in class, I would say how many degrees are in a circle, and you all would say 360, Ms. Hirschfeld. It's how many degrees is in a circle. And it kind of makes sense that if we look at this bottom theorem, sum of central angles, the sum of the measures of the central angles of a circle with no interior points in common is 360. So what this is saying is any central angles in a circle, if I add them together, they're just going to equal 360. So here, angle 1 plus angle 2 plus angle 3 will equal 360. If there were 4 angles, the 4 would add up to 360, and so on and so forth. Okay, so let's look at our first example. So our first example here, if we notice, they give us some angle measures. We know that angle RTS is 8x minus 4. Angle STU is 13x minus 3. Angle UTV, 5x plus 5. Angle VTQ is 20x. And they don't exactly tell us what angle RTQ is. Okay? So what are we going to do? How are we going to handle this? Well, so we know that an entire circle's angles add up to 360. That means that what does half a circle add to? Well, 360 divided by 2, which is 180 degrees, right? Since we don't know what angle QTR is, and it's not vertical to angle UTV, if you really look at them, those two angles are not vertical, so they're not the same, then I can only really use the right half of my circle. Here's my diameter, so RT is the diameter. So we're going to use the right half of my circle, and we know that these angles, if it's a semicircle, must add to 180. So we're going to say, okay, 8x minus 4 plus 13x minus 3 plus 5x plus 5, and what are they going to equal? 180 degrees, and we're solving for x here. So if I add these all together, what I'm going to end up getting is 26x minus 2 equals 180, and you can solve and you'll end up getting that x is equal to 7. Okay? Circle adds up to 360, semicircle adds up to 180. Now what about the circle on the right? Well, here we're trying to solve for x. We know all of the other angles. We know this angle is 90 degrees, 40, 85. So what am I going to do? I'm going to add all of these angles up, 40 plus 85 plus 90 plus x, and I'm going to set them equal to 360. And if I solve that, I will get that x is equal to 145 degrees. So basic angles add up to 360. Okay? Theorem 10.1 says, in the same circle, or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So two minor arcs are congruent if and only if their central angles are congruent. So my question here is, what is an arc? So an arc is just going to be exactly what it looks like. If you want to think of like a slice of pizza, it's like the crust on the outside, okay? So if angle 1 is congruent to angle 2, then you know that their arcs are going to be congruent. So therefore you can figure out what they are from there, okay? And if the arcs are congruent, so if I know that arc HJ is congruent to FG, then I know angle 1 would be congruent to angle 2. This is what this theorem is saying. Adjacent arcs are arcs in a circle that have exactly one point in common. And, you know, this isn't super important, so you can just read through that. But last but not least, the arc addition postulate. And this is going to make sense if you know the angle addition postulate or segment addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. Very wordy. All it's saying is that if we have arc XY and YZ, if we add them together, we're going to get arc XZ. That's really it. That's all that it's saying. So now, in the last slide, they talked about some vocabulary. What are my different types of arcs? So if we look, my minor arc is the shortest arc connecting two endpoints of a circle. So my minor arc here is AB. Okay? My major arc is going to be the longest arc connecting them. We always name a major arc with 3 letters, and those are always going to be greater than 180. So minor arcs are going to be less than 180. Major arcs are going to be greater than 180. Okay? And like I said, we will name them with 3 letters so that we know we're going around the circle and it's greater than 180. And then we know a semicircle is just 180. Okay? I know I'm giving you a lot of information here. Stop, check out my worked out notes, answer any questions, and then you can go back through everything. So example 2, find the measure of each indicated arc. So what we are going to do here is we're just going to find the measures of the arc, knowing that the arcs and the angles are congruent. So if I can find the measure of the angle, I can find the measure of the arc. So what do I know? Well, I know for the first one, whenever I do these problems, I always say, look at the circle they give you and find out any information that you can. So what I'm going to do is I'm going to look at the circle at the right. I want to first find arc AB, which means I'm going to try to find angle AFB. Now, if we look at this circle, everything I just marked down in red forms a semicircle, which means it's going to add to 180. So if I want to find AB, I can just take 180 and subtract off 63, and that should get me my angle AB, which is equal to my arc AB. So 180 minus 63 is going to give me my angle and my arc, which is 117 degrees. Okay, I'm going to clear out my picture, and I'm going to fill in that 117 so we can use it. Next, what else do I know here? Well, I don't know if you guys see this, but angle AFE and angle BFC are vertical. So that means that they have the same measure. Okay, vertical angles are congruent. Fill in anything you can find. So the only other piece I'm going to find and see if it's going to help me is I'm going to find angle CFD. So if I look, this part of the circle forms a semicircle, which means it adds to 180. So 180 minus 63 minus 90 is going to give me that little wedge up there, which will end up equaling 27 degrees. So I didn't even really look at the arcs they wanted me to find. I found all the pieces on the circle first, and that's going to allow me to find, my arcs and my angles. So part A we already found. Look at part B. It's asking us for arc ABC. It's 3 letters, so it's either going to be a semicircle or it's going to be a major arc, which means it's greater than 180. So we want to find A, B, C. So we're going to trace out A to B to C. And that arc is actually formed by a semicircle, which means how many degrees is it going to be? 180. Okay? Let's keep going. DE. So it's 2 letters. It's going to be a minor arc. So here is DE. They actually give it to us. Our angle, central angle is 90, which means our arc is just going to be 90 degrees. Okay? CD now. So we're finding CD. We already found that. It's a minor arc. The angle is 27. We found it by doing 180 minus 90 minus 63. So that means my arc is just going to be 27. AD. Let me clear off this diagram a little bit so we could see it a little better. So for AD, it's a minor arc, which means it's less than 180. If I go from A to D, I'm going to add the angles together that are in between there. 63 plus 90. That will get me my angle and my arc. So it should end up equaling 153 degrees. And then last but not least, we want to find EBC. It's a major arc because it has 3 letters. So I want to go from E to B to C. Now if you trace this, what you'll notice, from E to B is a semicircle, that's 180, and then I'm going to add 63. So it will then end up giving me 243 degrees. Okay? So go through that again. What I always recommend with this is look at the circle. Before you even look at what they want, look at the circle, find all of the angles you can, find all of the arcs you can, and then look back at what they're asking. Most likely you'll need most or all of the pieces to fill in the problem. Okay. Let's see. Okay. So from here, the last little bit we're going to talk about today, I believe, is arc length. So what is arc length? Arc length is the distance between the endpoints of an arc measure. So this makes sense to us. Now, it is a portion of the circumference. Here's the difference. When we were talking about arc just now, we were talking about the angle measure of the arc, the angle that the arc sweeps. Okay? This is the actual measure. So this would be, like I said, if I gave you a slice of pizza, the arc length is going to be, you're actually going to measure the crust. So maybe the crust of your pizza is 4 inches. That would be the arc length. Meanwhile, if I told you my arc swept a 40-degree angle across my pizza or something like that, okay, that is the difference. Arc length is length. It is a distance, portion of the circumference. Here is the formula that you need to know for arc length. When I say you need to know, I mean you're going to have it in front of you for everything that you do, but you want to know how to use it. And basically it's saying part over whole, part over whole. So the ratio of the length of an arc to the circumference, so length to the circumference, is equal to the degree measure of the arc over 360. So it's a part of the circumference over the circumference equals the part of the angle over 360, the total angle measure. And let's see how to use this in these last 2 examples. Find the length of, I believe it says ZY here. So we are finding the length of ZY. And remember, this is arc ZY. So we are finding the length of arc ZY. Okay? And the arc length formula says degrees for that arc over 360 equals my arc length over my circumference. So these are pretty loaded questions. So if I look at arc ZY, this is the length I want to find. You can call it whatever you want. Maybe I'll call it A, or you can call it X if you prefer that. I know a lot of you like X. Where is my angle measure associated with that? 130. So the first thing I'm going to fill out is I'll have 130, those are my degrees, over 360 is equal to my arc length, that is the piece I don't know, over my circumference. Here's the issue. Did they give you your circumference? I would hope you say no. But we know from earlier that circumference is pi times diameter. And what they do, if you look, they give me my diameter. So my circumference is just 10 pi. So we're just going to put in our circumference down here. And now, as messy as it is, we're just going to cross multiply and solve. So to cross multiply here, I'll take 130 times 10 pi, which is 1300 pi, equals 360 times x. I'll divide both sides by 360, and I get that x is equal to 11.34 centimeters. Now, what is x? This is the length of arc zy. Remember, it's a length. It'll be in units, inches, centimeters, anything like that. So what do? I'm finding arc length. I need the degrees over 360 equals my arc length, which is my variable, over my circumference. And I can solve. And last but not least, our last example says, find the length of the radius given the arc length. So how are we going to do that? Well, we are given our arc length. Which arc are we given? We're given our major arc around, which is DE. And typically they would put another letter in there. So we're given that arc. So we're still going to use the arc length formula because that's what we're given. So what is that formula? Again, degrees over 360 equals arc length over my circumference. Now, it says nowhere that there's a radius in here. But let's figure this out for a second. Our arc length we are given. Let's fill in the pieces we know. Our degrees were given. So we know our degrees is 290 over 360. Our degrees for our arc. We know our arc length is 46.75. What about circumference? Well, we don't know that. We need a variable, and we're solving for the radius. So isn't there a circumference formula that is in terms of the radius that we talked about in the last section? Circumference is equal to 2 pi r. There's where the r is going to come in. So rather than circumference, I'm going to actually put in 2 pi r, and I'm going to have to solve for r. How? Let's cross multiply. So I'll take 290 and multiply it by 2 pi r, and I'll get 580 pi r equals, and then 360 times 46.75 will give me 16,830, and then I want to get r alone. So I will just divide both sides by 580 pi. My radius will just end up equaling 9.24 feet. Okay? So, they're giving you the arc length. Even though you're not solving for it, you're still using that same formula. You're going to plug in. Plug in for the circumference, 2 pi r. We're solving for r. Cross multiply and get that alone. Once again, if you look at your note sheet, I have online with this same post your blank notes, if you want to copy these down as you go along, and some try problems. The try problems are not in the video, but they are worked out in the other PDF, which says worked out notes. Okay, if you go there, they'll be worked out, so you can check your try problems and ask me if you have any questions. Your homework will be up there. You can complete that, and make sure you're keeping updated on your posts and homework so that we can finish the marking period strong. Good job, guys.